So it's a pleasure to have you here, man. I've been really excited to talk to you. I feel like you have very interesting takes and ideas and frameworks. Can you please introduce yourself and tell us a little bit about your background?
Yeah, so my name is Ali. I did my undergrad in CS and started working in the industry in the last year and for the few years after that as well. And then I went to grad school, started as a master in software engineering, and then I started doing research in a field called molecular computing, which is a mix of complexity theory, theoretical computer science, and molecular biology and evolutionary biology. And that took me to sort of a rabbit hole for a few years. I was shuttling back and forth between the computer science part and the molecular biology part. And it was an interesting journey there. Basically, we were trying to address one of the open questions in evolutionary biology about the reason why genetic interaction networks look the way they do. They have a very distinct topology, and generally speaking, we were trying to find like an explanatory theory for why it is that way. And yeah, the short story of it is that, what we try to show is that what nature tries to do is, instead of trying to tackle hard problems, it basically tries to go to an easy regions of the search space. So if the organism is under some evolutionary pressure and it needs to amend itself to survive through random variation followed by non-random selection, if it had to do so much search, it would die before the random variation, non-random selection finds a good solution. Instead, it structure itself, the interaction genetic network, in such a way that makes the alteration a lot easier. And that also involves some experimental demonstrations. So I found myself in molecular biology labs and got my hands wet there as well, doing some experiments. And then after finishing my PhD, between the time that I finished PhD and starting postdoc, that's when I found myself in ETH Waterloo in 2019. So I participated in that hackathon, and shortly after that, I decided to join the Ethereum ecosystem. I was attracted by some aspects that were refreshing in the ecosystem. Things like, quick feedback on research, the openness of it, the, you have a research post, just go ahead and post it in Markdown. There are no PDFs, there are no long waiting periods for peer reviews, things like that. So it was refreshing. And so I was doing that for a while. I had like a Gitcoin grant as well, which helped a lot as well, and encouraged me to do a little bit more. Then, and then DeFi summer happened, and there was a lot of crazy things happening in the security side. So there was basically almost a hack per day, like high profile hack where, we would be watching something getting drained live almost every day. So I had this idea of, how do we scale this? We know that the contracts are going to keep coming. People are just going to keep, launching stuff in production. But then if we keep having these high profile hacks, the ecosystem at large is going to take a hit, basically. So it was just this idea that I didn't think it would work as well as it did, which is, we can't stop auditing, and we can't do traditional way of training where, go top down, or you train people somehow and you give them sessions and homeworks and things like that. That's not scalable. We need to 10x the number of auditors in the space. So the idea is to, audit the same way you do usually, but then in a very low overhead way, bring in aspiring auditors or fellows that we call them to shadow along and follow quickly. We put a lot of emphasis on them getting so far ahead on their own and catching up. So it worked really well. These fellows, people who have never done auditing before, they actually found a lot of bugs, which was surprising in a good way. And the people we audited in the early fellowships, we were auditing mostly for Yearn. And Yearn team, they have some of the best security-minded developers in the space. So that was actually also great in that the fellows were getting a lot of good feedback, basically. So some of these fellows ended up being top auditors themselves. Some of them decided to stay and help with the next batch of fellows. And that's how yAcademy and then yAudit were born. So yeah, we have done a couple 6 fellowships so far. A lot of people recognizable in the space now, solo auditors or auditors in some of the best auditing firms now. They have been discovered through the program, which is great to see. Recently, the most recent thing is actually us trying to get into the zero knowledge space by auditing zero knowledge code bases. So we had a pilot fellowship last summer, and it was great. And we also found bugs, despite the very steep learning curve. And once again we did discover some promising talents who are still with us, and they will be joining us as well in the next zero knowledge focused fellowship. So yeah, this is sort of the background and how I got here.
Yeah, awesome. There's a lot to unpack here. I'm not even sure where to start. I think your background is so cool. Would you call it bioinformatics, or is it like a separate category altogether, the molecular biology?
Conceptually speaking, it's sort of the inverse of bioinformatics. So in bioinformatics, you're taking biology, you're taking the cell or a protein or DNA or RNA molecule, and you're taking it into the computer and doing some sort of simulation or analysis or something like that. So you're taking something from in vivo or in vitro and you're taking it in silico. While what I was doing is sort of the opposite of that. You're taking something like NP completeness and intractability of certain search problems, and then you're taking it into the cell and you're saying the cell looks this way because of NP completeness. If the organization of the genes, the active genes at a given point of time, looked any different, the process of random variation by non-random selection would be extremely inefficient. It will not be able to find more and more fit organisms. So yeah.
Are you familiar with this guy called Michael Levin? He's a scientist at Tufts University, I think. And the things that you mentioned you were working on and trying to understand how or why the evolutionary processes are not really random because they choose the easiest path. It's really similar in a way to this guy's work, even though it comes from a totally different perspective, where his research focuses on the intelligence of organs as if they have their own type of I don't want to say consciousness, but they have problem solving abilities. For example, if they can get like let's say you have an artery that's supposed to be, you know, this long and like 10 centimeters long and supposed to have like, I don't know, 100,000 cells or whatever. They did some studies where they would change some things in the organism where it didn't have 100,000 cells to make up that artery or whatever. And then the organism would find a way to replicate the same structure using different processes just to achieve the same thing. Like, so like, you know, you originally you would argue that you wouldn't be able to do that because it's just it's not like encoded, or it's like doesn't never encountered this kind of thing in nature. But it doesn't work like that because it's able to achieve the same structure with like 2 super big cells instead of 100,000 cells. And it just reminds me of, it's very similar to this idea that there's some problem-solving agency in the evolutionary process, not just random. I'm not sure if that made any sense, but I think you would find really interested to look into his research.
Yeah, that's interesting. Yeah, I have come across ideas like this. For example, growing limbs, fish that would grow certain limbs if you somehow interfere with the specialization of a cell, because all cells, they start basically like babies, pure from the bone marrow, and then they go on and they become a heart cell or a brain cell or something else. So the path from being born as a cell to specialization is fascinating, and it's not really solved 100%. We still don't know how or why, because if we did, we would be able to, on demand tell the cells to differentiate. They call it differentiate into what we want, into, for example, a damaged. If you have a damaged lung, then we want them to recreate the lung. But it's extremely complex, and we haven't found a way to really control that process. But to your point about like being random, the cell differentiated into a specific thing is definitely not random. But if the cell or if the organism is better off doing something else, directing 30% of the cells into something else as opposed to what it's doing now, for example, then we don't know of any non-random process that would take it there, basically. So yeah, as I said, what I try to show personally is that getting to the finish line, or getting to the correct state from a bad state, is extremely intractable. But what nature did is said, let's stay in the easy regions of the search space. So if we have to compute something new, to be different from where we are right now, it wouldn't take so many generations. So yeah, a lot of fascinating avenues in the area.
Yeah, we could spend the whole podcast talking about this, but maybe for another time, because I think we were supposed to be talking more things related to crypto.
Yeah.
So maybe we can do a second take or just on that kind of stuff that I think is really cool. So backtracking a little bit, how did you go from academia to blockchain research? What made you make that change? Because they're seemingly unrelated. What sparked you the interest in crypto in the first place?
Yeah. So I excuse me. I did hear about Bitcoin, and I learned what it is early on. I was totally not interested at all. It just wasn't of interest to me. But when I discovered Ethereum, like a Turing complete platform, that you can permissionlessly push application onto. That was interesting. So that was the beginning of the thread. And I had some time between PhD and postdoc, and Waterloo was close to me, so I found myself in the hackathon. I was like, let's just go and see it. And it was a quiet time at that time. In 2009, there wasn't any, like, crypto was not really in the news or anything. But I was really impressed by, as I said, by how quick you can get your idea out there and get feedback. It's and the quality was extremely hard. I looked at the scalability research that was happening at the time. It was extremely vibrant, which if you looked at crypto at the time from a market perspective, you would say it's dead basically. But from a research side, it was extremely active. There was a lot of debates, a lot of competing ideas, a lot of arguments, I would say. So that was what attracted me to it. Coming from academia, where there is so much
red tape.
Yeah, exactly, and overhead, and like PDF centric processes, which I did not enjoy at all. So yeah,
I don't think anyone does. Hey.
Yeah, exactly. I think that the academia is still stuck in the 1990s. Even on websites where you would, apply to conferences or submit something, the whole process is just unpleasant, I would say. And part of it is, peer review is not incentivized. People are just working. It's a public good, and it's not incentivized. So in a way, it's not surprising that it is that way. But yeah, so the Ethereum research was refreshing, I would say.
Yeah, it's such a different landscape coming from academia specifically, because the pace of iteration is a total opposite. So it must have felt really refreshing. And then you got into this research. And at what point did you start getting into security?
Yeah, that was in 2020 during DeFi summer. So I started contributing in the Yearn community. It was an exciting time. There was a lot of optimism, I would say. You have a strategy, you have a way to allocate capital in a smart way. Go ahead and build it. We will build it together. And the community was very vibrant. It was collaborative. And DeFi, I had known about DeFi, and I toyed with it in the months before that. So I was familiar with it. It was fascinating to me that you can, get a loan from the command line. So all you have to do is, get the ABI of some Aave or Compound contracts, and then from the command line you would just, So I was doing fun things like that. Toyed around with liquidation bots as well. At that time, MEV was, it was in the air, but it wasn't as competitive as it is now. But it was after the DeFi farms were exploding, and people were just jumping into these pools, and there was a lot of hacks almost on a daily basis. And there was so much pressure on parts of the community, people like Samson and the security team at Yearn as well. Because every time there is a hack, oh my God, can you help? And there's so much stress, so much anxiety about it. So I didn't consciously say, I'm going to solve this problem. I just made this proposal about this way of collaborative learning, trial by fire learning, I would say, which could help. And for a while, actually, the proposal was popular, but no one wanted to take the lead, and people kept, every once in a while, people would say, oh, what happened to the proposal, the yAcademy? I was like, it's there, go ahead, do it. But after a while, after getting so many people asking, is this happening? We need this, etc. I was like, okay, let's just do it and see what happens. And very quickly, I was joined by Kat, my co-founder. He came in. He came in actually as a fellow, but very quickly, within 2 days, he was already he was advanced already. He knew how to audit, but he was also helping in all directions. So it emerged very quickly into a thing, and it has been an amazing journey since then. The reason why I continued doing it is, as I said, it was working really well. We were finding bugs every time, a lot of bugs, even in code bases that have been audited before. And the virtuous cycle that I call it, where top fellows would come back and help train the next batch or mentor the next batch, also worked. So I got into it by, I'd say, it wasn't a very conscious thing. I just found myself in it basically, and it was fun. It has been fun to be part of it.
Yeah, it sounds like it's a really organic process while you're going through the fellowship. And I think it has to do with how it got originated in the first place, from what you said. But how does it work exactly? So do the projects pay for having their code audited during the fellowship? Is it something that you guys are already working on and you just use that as an opportunity to onboard more people? How does that part of it work?
At the beginning, early on, we were just telling projects, if you get value back, you can donate whatever you want. But then as by the third fellowship, I would say, it started becoming valuable enough. Our audits were competitive with other auditing firms, to the point where people are willing to pay for it. And the majority of the auditing fee, it goes to the residents. By the time we started charging for audits, we had a team of residents. These are fellows who graduated and were invited to stay as residents. And then part of the fee, a small part, goes back into funding the public good part, which is the fellowship, organizing it. Sometimes we give awards also to top fellows, things like that. So yeah, this is right now. In the last fellowship, it has been getting more competitive. So we're getting a lot more applications, and we can only accept. We used to accept only 12, but then we increased it to 20 because we, as a core team, grew as well. So we are able to handle more. Fellows, we receive a lot of applications, especially in the last two fellowships. The acceptance rate is something between 5 to 10%, something like that. And so this is. I hope that answers the question.
Yeah, and how do you select the best candidates?
So we don't require prior knowledge of, say, smart contracts or zero knowledge in the ZK track, basically. But we do require proof of brain or proof of work elsewhere. We do this because from our experience, some of the best fellows that came out and became top auditors in the space, they actually had no auditing background whatsoever. Some of them did not even come from a CS background, or they barely had any programming background at all. So one of the things we realize is that the auditing brain seems to be unique. And in order not to have people like that fall through the crack and we lose them as an ecosystem, we started paying attention to clues, basically, in someone's track record, something they did on GitHub, or something they wrote on a technical blog or something like that. So I would say 70% would depend on track record and what they have out there, and then we reserve, say, 20% or so on wildcards, people that we instinctively think would would surprise us in a good way. And we were often correct. In every fellowship, there would be one of those people that we take a chance on, despite the fact that their background does not really scream "oh, future auditor." And we are always happy when we turn out to be correct. So it's a mix of screening, like quizzes, interviews, things like that, and us meeting and arguing for this person or that person after we filter through like the many applications.
Yeah, it definitely makes sense that it's hard to really anticipate who is going to be a good auditor, because coming from a different background is what gives you a particular edge and going to make you like set yourself apart as an auditor. But how do you instinctively find those people? Did you guys found some sort of pattern or some nuances? I know this is more like a soft skill and more like a feel rather than a science, but can you elaborate maybe on what are the things that, or what are the clues that might lead you to selecting an individual that doesn't have the classical technical background or CS background? What are some pointers that guide you guys into making that sort of decision?
Yeah, so one of the things that I personally can look for is curiosity. And I try to be on the lookout for people who lean into the darkness, lean into something very difficult. So you might come across someone who hasn't done anything on GitHub for anything of significance on GitHub for forever. But then recently they have been toying around with, say, Huff compiler, and they're trying to, they latched into something and they kept digging at it, and they shared what they were working on, and they formulated their learning into something different, something that I haven't seen before, for example. So any sign of curiosity and not being afraid of venturing into something totally new to someone, this is something we look for. So there is usually something that someone has done that is, it may not be good, it may be totally bad or just a toy thing that they were sharing, but the fact that they shared it publicly and they were not afraid of being wrong or whatever, and the fact that they actually were curious about it tells me that, okay, this person is curious, they have enough passion, things like that. And this is especially true in the case of ZK. A lot of people are curious about this thing. What is this thing? So the vast majority of people would go and read some articles about it and try to get a sense of what this prover verifier model is, and they might tweet about it or something like that. This is not what we're looking for. But if someone say rephrased, let's say they created a metaphor about the prover verifier model, and that was insightful enough, and we'll say, okay, maybe. So that would encourage me to look more into their background, and if they happen to be exceptional in some other way, in something not necessarily technical, maybe something in finance or something like that, and they mentioned their interest in the application, then I would flag people like that.
Yeah, interesting. And for the ZK fellowship, do you follow the same thread? There's just trial by fire, whereas there's no educational material, because I imagine that would be a lot harder to pull off with ZK just because of the upfront cost of the all the mathematical that you'd have to cover.
Yeah, with ZK, we actually had to think about this a lot and put forward a plan as to how to approach this beast, basically. So in general, our my motto is, what is the shortest theoretical path that can get us to the code? And so our approach is not top down. We don't tell people before the fellowship starts, oh, here's a list of curated materials, go ahead and go and read it. Before the fellowship starts, it's going to be trial by fire, you need to catch up. That's not going to work. The materials that is out there about ZK, they're all excellent, they're all amazing, different level of depth. Some of them are general, some of them are technical, and so on. But one thing I realize is that they all start with this with this picture, prover, verifier, and then defining it and then taking it from there. And so if I were to put my shoes in, if I put myself in the shoes of someone who has no CS background whatsoever, they may understand the whole post. They may understand what a prover is, what a verifier is, how it works and all of that. But they may not have a grip on why it works. Where did this thing come from to begin with? Who was the very first person that said, let's have this model, prover, verifier? Where did that actually come from? And the story behind it, or how that came about, is actually not that difficult. And it's not that complicated, and it doesn't actually involve a lot of what people usually refer to as moon math and all of that. So there is 50% of the ZK snark machinery is complexity theory of computer science, which concerns itself with questions of what can we in principle compute and how efficiently can we compute it. So it's a computational model. And you can compute on a Turing machine or something that simulates a Turing machine, like our modern day laptop, for example. Or you can compute with a different model in which you have two machines. One we call a prover, one we call a verifier. And the reason why you would do that is that you want to create an asymmetry in the amount of work that is done between these two machines. And in the early days, the prover verifier, they were actually two sub-processes thought of as two processes of the same machine, really. But today we usually think of them as, the prover is someone off-chain and the verifier is a contract on-chain or something like that. So the model lends itself to the blockchain space because of the asymmetry we want to create between the two processes. And because the users we typically want the users to not to spend too much compute, basically, because we want to target people with mobile devices, things like that. So what we try to do is explain this first half, the computational model itself, where it came from, and what is involved in this part is actually very, very simple. You start from code, from a problem, and you compile it into a system of polynomials. We are all familiar with compilation in general. We all know that when we're watching a cat video on YouTube, there is no actual cat inside the computer. Instead, a developer expressed their intent for frame movement, moving from one frame into the other, in some English-ish language, and that was compiled by a compiler into a binary, which runs on some architecture. So deep down, we do know that nothing happening except Boolean arithmetic in circuits. So the difference in zero knowledge is that we compile, instead of compiling into a binary that runs on some laptop, we compile into a system of polynomials. So that's the first half of the story, basically. The second half, where all the math and the difficult stuff happens, is how do you probe this resulting system of polynomials such that you make a statement about the entire system of polynomials, and as a result, indirectly about the original computation that was expressed in some language, let's say Rust or Solidity, without actually having to compute the entire system of polynomials. And that's where all the shortcuts, all the magic happens. You know, you have polynomial commitments, you have modular math that helps us stay bounded in terms of results when we multiply and stuff. We don't, the numbers don't just keep growing and things like that. So this other half, where you apply all these number theoretic and abstract algebraic tools, is where the difficult part is. The good news is you can attack each one of these protocols involved on the verification and proving side in isolation. You don't need to understand SumCheck to understand polynomial commitments. You don't need to understand pairing in order to understand erasure coding. So the first half, the reduction half, you need an overall top-down understanding, and on the second half, the mathematical half, you need bottom-up. You need to attack each one of these in isolation. So long story short, what we try to explain to the fellows is this organization. This is like the metro map of Tokyo. So you still don't know how you don't know every corner of Tokyo, but once I explain to you how the metro system works and I give you a map, at least you will know where you are. You will find your way back home. And over time, as every day in the morning, you venture out and you find your way back, you venture out and you find your way back. So through this map, you start getting more and more familiar, and to a point where in the future, you'll be able to, move around without the map in your hand, basically. So this was our approach, really. And it's not something we completed. It's something we started in the first fellowship. We will continue through this strategy, basically explaining the reduction half and the proving and verification half using two different methodologies, basically. And we do emphasize to people, okay, this is exactly what you need to understand before we can get to the code. Don't try to venture out and absorb other things. Don't be tempted into reading too much. A lot of people sometimes, they glorify hard work. They say, oh, I'm working hard. I'm reading everything thrown at me. I'm going to make it, etc. And I really don't think this is the right mindset. What we should be doing is, what can I afford not to look into? So it's not about how much material can I curate for myself in order to start reading one by one. It's your instinct should always be, can I skip this thing? How much can I skip without jeopardizing my understanding? So in the pilot was short. It went too fast. A lot of people could not make it all the way to the end. So it was very fast, but the code bases were simple enough. They were circle code bases, and the developers who were with us, the code base authors, they were amazing. They were present throughout the fellowship, and overall, it was a positive learning experience. But we did realize that we need more time. We need, instead of 5-6 weeks, we need 4 months at least. And we need to continue with this strategy of we are in a forest. What you need to know is where you are, as opposed to knowing every corner of the forest, because you can't anyway. There is probably 3 5 people in the world who can comfortably go from theory to implementation and back. Most people just have an advanced understanding of one part of the forest. So we emphasize this notion of, understand your place in the forest, understand how to navigate, how to come back and forth. And here is a helicopter view of how the forest looks like. So you can, or this is, the map of Tokyo, basically.
Yeah, so it's kind of like a more modular approach,
Yeah, I would say so.
kind of like a divide and conquer.
Yeah, absolutely. You need a plan. If you wanted to get a grip on this, you need a plan, because you have to understand, like, ZK was not born in the past 2 years. It has been accumulating for 40 years now, maybe. Yeah, 30 years, I would say. And so there is mountains of stuff to go through. So really, your task as an auditor, especially, is how do I develop the skill to know what can I skip, and the stuff that I cannot afford to skip. What is my plan to understanding them?
And do you have somewhere public where people can assess that framework that you guys built, that they can use it as a guide, or is that not entirely finished to be published at the moment?
No, it's out there. We did open source the entire pilot fellowship from the ZK fellowship. So people can go to the website, yAcademy website, and they will find all the materials. So module 1, the first 2 weeks, it was more about understanding this computational model, prover verifier, as a computational model itself, where it came from. And then in the middle and end, we started attacking specific concepts on the mathematical part. The part that starts after you have the polynomials already. So we had one session on pairing, we had one session on Plunk arithmetization, and how it compares to the arithmetization that we were auditing, which is R1CS. So the pilot there is enough there to give people a sense of this approach, and from the feedback that we got from the fellows, this was working well. So we will continue along the same strategy. We will have a few more sessions in the future about the computational model, and then we will have more. We will one by one attack each one of those concepts, like erasure coding, sum check protocols, specific instantiation of polynomial commitments, things like that. And we will do that in isolation, basically. Each one of those can be understood just by itself.
Can you direct me? Sorry to interrupt. I'm just trying to find the page you just mentioned, but I can't really find the structure of it.
If you go to yacademy.dev/fellowships, thank you, and then you click on ZK fellowships, it should be
okay. Yeah, pilot ZK. All right, got it. Thank you. I just wanted to make sure I knew where it was, because I'm gonna share it later when the video comes out. Sorry to interrupt. Please go ahead.
No, that's. I think I was done. I think.
Okay, cool. Yeah, no, I think that's a great start, because then people that are not accepted to the fellowship, they still have a chance to try and make it on their own if they're sufficiently motivated. As you said, having the framework and having a plan and a structure, it's kind of like half the battle. So that already allows people to try to make it on their own. And do you find that the selecting the candidates between the Smart Contract Fellowship and the ZK Fellowship follows kind of like the same criteria, or do you usually have different criteria for these different fellowships?
Generally, it's the same approach. We For the smart contract fellowship, we have gotten pretty good at assessing candidates. But in general, I would say it's the same philosophy. We select 80% based on hard evidence of proof of work. Again, it doesn't have to be specifically in the smart contract or ZK, but technical work in terms of research or development. And then there is the 20% that I mentioned that we take a chance on, just based on not so strong evidence, but an evidence of an outlier, someone who is definitely not there, and there is no evidence that they will be, but there is something special. They did something that shows curiosity, that shows dedication to sharing work, dedication to learning, not being afraid to ask in public, things like that. So in general, it's the same strategy and philosophy.
Yeah, I guess that makes sense because ultimately it is a very similar challenge, even though the ZK one is a little steeper. At the end of the day, it's like you're climbing the same mountain. It's a very similar sort of mindset, I would say. The security review, curiosity, diving in deep holes kind of mindset. It lends itself so well to so many different fields that I think any really good smart contract security researcher would do really well in ZK if they apply themselves to it. Would you agree with that?
In general, yeah, as I said previously, I do believe, based on experience, that the auditing brain is unique. So someone who has the stamina to lean into a very math-heavy piece of DeFi code base is probably also going to have the stamina and the curiosity to lean into ZK and be uncomfortable with themselves for a while until they get it. Because I mentioned the word stamina because in auditing, you cannot afford to abstract anything away. You can't say, well, this part of the code, I don't really understand it, so I'm just going to leave it aside, because that breaks the whole thing. The problem could be there, or maybe there's no problem there, but when you connect that function to other things, then you get a problem. So you can't really afford to abstract anything away. In general, I think a good auditor is someone who is able to lean in and be uncomfortable for a while, be uncomfortable of not understanding, of looking into something in every audit. There is definitely something that will challenge you as an auditor. It's not like, over time I can quickly read a code base and understand it, because you may understand the syntax of the code, you understand Solidity really well, but you still have to understand the mechanism, let's say, of a new DeFi lending protocol, and you have to understand potentially new paradigm of reporting oracles. Let's say, it's the same exact lending protocol, but now they use an optimistic oracle. So you have to really understand the implication of that. Yeah.
Yeah, I think that's what people find so attractive in auditing as a career as well, right? Is the constant novelty. Unless you're auditing, forks for the 100th time, there's always something new there. There's always something that is done slightly different. There's always something that you're not really familiar with. There's always innovation. And that's part of what makes it so nice, part of what makes it so rewarding. And we've been talking about audits now, so what is your view on the terminology between security review and auditing?
I definitely prefer the word review. The impression that people should get from seeing a code that has been looked into is that this has been looked into. It's probably better than before, but that doesn't mean it's the end. In general, I think people should look into security as a continuous thing, something that you do over and over, and you do it from different angles. So you do a traditional security review, and then you do some bug bounty, and then you do re-review maybe a year from now after the developers, let's say, had some time to distance themselves from the code, and then they look at it again. So I do hope that people get the impression that an audit doesn't mean that it's all the problems have definitely been found. So I think even at our reports, we don't use the word audit anymore. It has been since the very beginning, since early on, we use the word security review with a clear disclaimer that, by the way, a security review doesn't mean that this thing is 100% safe. And we do sometimes explicitly tell some people, hey, by the way, if you plan on doing such and such as you told us you might, that may require you to do another review if you're doing certain new integrations, things like that, because sometimes the bug is not in one place. It's about connecting two things together. That's how the bug happened. So yeah, I prefer the word review.
Yeah, I agree in the sense that review it's way more semantically accurate and sets the right expectations for the client. But on the other hand, audit is such a better marketing terminology. I think security review is just long, and it's hard for someone sort of like out of the industry to kind of understand what that means immediately. What do they get for it? Whereas audit, it's kind of like it's a shorter. You have to go through less mental cycles to figure out what happens in an audit, I think. So I've been trying to think of a different term that I feel like it would satisfy both requirements, but for now it's still still kind of like that weird situation when sometimes you say auditing, sometimes you say security review, and ultimately I feel like it would be nice if the industry could just converge to one at some point.
Yeah, I don't know if we're gonna succeed at convincing projects to remove the word audit, because as you said, they have incentive to market it. But I would hope that at least the auditors themselves, security firms, security DAOs, things like that, would agree that the word review or assessment is better. And actually, engineer from our team, he has been doing a lot of great work in establishing standards in general, assessing the quality of a report, the depth of it across many dimensions. And one of the issues that he is hoping to standardize is this terminology, basically. So I am not so optimistic that the ecosystem at large will get rid of the word audit, but hopefully at least the auditors themselves will start using the word review, so that after you click on the link to it, the marketing link to it, at least the report will not say will not use the word audit.
Yeah, that's an interesting problem and very challenging as well of assessing the quality of a report, because there are so many variables and it's somewhat subjective. So what approach is him taking to trying to standardize that?
It is still in active development. Engineer has put some stuff out there for people to look at. I think it is under his GitHub. I can try to look for it and share it afterwards. But yeah, as you said, it's about finding an objective way to say reduce the ambiguity or the openness of or the subjective nature of these things. Things like labels, high, medium, low, things like that. It's not easy. It would take a consortium. It would take goodwill of so many people. It will take some critical mass to end up being adopted. But yeah, I would encourage people to look into what engineer put out there and see if they have feedback on it. And yeah.
Yeah, I think it's a very important part of the industry to try and have, I want to say call it a standard, but some sort of mutual agreement on, and I think we've been going towards that and go for quite a while, and a lot of things are already, let's say, standardized, but definitely a lot of room for improvement for sure. And switching topics a little bit, I know that you have a very interesting Substack, a lot of interesting articles, in particularly the one that I sort of found very interesting is the investment thesis of a blockchain developer that kind of has a different approach that I haven't seen anywhere else. Can you please, I know you wrote it a while back, but if you remember it, can you run us through it and like elaborate on what your thesis is? And has it changed? Because it's been, 3 years ago that you wrote that?
Yeah. No, it hasn't changed, actually. I would argue that the thesis has been vindicated, I would say. So just to give some background on it, like I actually wrote that for myself. I was, beginning to do some research in the Ethereum ecosystem generally. And I was thinking, what is it about Ethereum that is, it can't be just the unicorn or the community or the vibe. There has to be something more concrete. And so I typically people talk about investment thesis in terms of capital, how much you should invest in something. But for developers too and researchers as well, your capital is your time. Where are you going to invest it, basically? And I try to take a step back and say, what are blockchains for? What are they here for to begin with? And I basically reduced it to the notion of a blockchain as a security API. It is just like an API that you plug into in order to establish some trust without an intermediary with someone else. And so naturally it follows that the most viable blockchains long-term are the blockchains that are secure or have a viable path towards security as they get more and more traction. So there are some like details just to formalize my approach. If I remember correctly, there was a couple of step-by-step. So there is more meat on the bone when it comes to this thesis generally, but it's basically this, like security. It puts security at the center, and something might be secure at the moment, but is it going to be secure if the number of users 10x or 100x, let's say? So it has to be durably secure. if it gets more traction. And my conclusion at the time, and it's still my I still believe in it today, is that generally sharded blockchains are the most secure, and they have the most viable path, because if they get overwhelmed with usage, there is a way for them to handle it, basically. And if I remember correctly, I do remember that if my thesis is incorrect, one of the one test that we can do a few years from now, if this thesis is incorrect, is if Cosmos got more traction than sharded blockchains, things like Ethereum and Rollups, or Polkadot and Parachains and Near and so on. And it just so happens, actually, in the past weeks, that you see in Cosmos their embrace of the modular approach. So they are thinking about, okay, how can we adopt this and start dumping data somewhere and putting commitments somewhere else and things like that. So I think in this regard, it has been vindicated. Like, app-specific blockchains have not flourished. Side chains generally have been probably the biggest nothing burger in the history of blockchain is side chains, because they are neither L1s that try to fight for a piece of the pie as something independent, and they are not something as convenient and as fast as AWS. So they are somewhere in the middle, which makes them not attractive. So since the time of the article, obviously Rollups matured. General compute in zero knowledge, to the surprise of myself and everyone, also is in production today. And so, in terms of adoption and in terms of vitality and vibrancy and developer attention, I think sharded blockchains are getting the most attention. So that's the idea, basically. And I think that recently I was talking to auditors, and I told them that the same thing. Instead of saying developers, you can say auditors as well, because as an auditor, you want to invest your time in the ecosystems that will bring you a lot of work, so that you can use the same thesis as well.
Yeah, I think that's a great approach, and it kind of links in well to your most recent blog post that I think is titled the era of Zk everything, or something like that, that really dives into how this modularity and the possibilities that Zk enables are gonna kind of take over the ecosystem.
Yeah. There is a lot of exciting things happening in ZK. And I'm not talking about ZK rollups or new proof systems. These are all amazing. They're out there, etc. But there is a lot of other things that probably most people are not aware of at the moment. But I would say they will have a huge impact. And the way I think of it is, ZK is going to bring about the final piece that we need before onboarding, the 1 million developers that we have been dreaming of, by basically abstracting away the blockchains with an S, plural. If you think about it now, if you develop a Web2 app, depending on the app, but sometimes all you have to do is push to GitHub, and then a whole series of orchestrations will just happen for you, and you don't have to do anything else. So Netlify will compile your site and publish it, and they themselves will outsource some other level things to other people as well, like they say DNS or something like that. They would outsource network level security to AWS. They would, so there is a lot that happens after you type git push, without you being aware of it. Depending on the app, like if you are creating something, if the app itself is something around networking or something like, let's say it's a SaaS, for example, then you might, descend down the stack and fiddle around with it or customize it to your need. But in general, you do have the option of abstracting away the entire thing. And that's something that we developers could not do in blockchains up until today. They still have to think of in terms of transactions, mempool, gas fees. Oh, it's in Ethereum, but my users would like this NFT somewhere else. Things like that. So they still need to think in concepts that are hard coded into the platform they're running on. While in Web 2, you don't think you don't have to think in terms of concepts like Kubernetes instance or things like that. You can abstract all this away from yourself, and that's why you can build and iterate very quickly. Going back to ZK, we can finally now abstract away the blockchains because of what is sometimes called ZK coprocessors or validity or storage proofs in general. So you can now have a zero knowledge proof about a piece of state in Ethereum and present that piece of proof to some other blockchain. Let's say, I don't know, Polkadot or another Rollup or Near or something like that. And then proof also something else on there and then bring it back. So you can have the entire, basically the space between blockchains is going to be steamrolled using these validity proofs. Now imagine with me, it's still early on, but imagine an SDK built on top of these low-level storage proofs. So you have individual discrete proofs about certain parts of each blockchains, and then you have one layer of abstraction above that turns multiple proofs into one higher level concept that we call it a session. Web 2 developers are familiar with this notion of a session, of a game developers are familiar with this notion of saving progress in a game. If my user is playing a game, I want a button that they click and it says save my progress so I can continue it tomorrow. Now, in the blockchain context, saving progress could entail so many things that happen underneath. You may have to touch so many blockchains for that progress to be saved, quote unquote saved, basically. And up until a year ago or a few months ago, the developer would have to have dealt with low-level concepts in all the blockchains that their game touches. But with these validity proofs, system programmers will be able to create the SDKs that abstract that whole thing from the developers, so that the developer will just say, import such and such, and this is immobilize this progress up to this point. And they don't know that underneath there is some data layer that is being touched, there is some assets that it be moving around and things like that. So up until now, this was not possible without inserting trust somewhere. But with storage proofs, we will be able to finally provide the necessary abstractions for developers to create real cross-chain applications. I emphasize the word, I said real cross-chain because this idea of cross-chain has been abused over the years by marketers to, create nonsensical stuff, which, most of them, if you remove the mask, they are just side chains underneath, up until today, basically. But because of the word cross-chain and because it lends itself to PowerPoint engineering, you create all these graphics that represent blockchains, and then you have pipes between them, and then you have bolts and things flying around. It lends itself to marketing adult projects, basically. But what I'm talking about is the real deal, and I think we'll get there soon with zero knowledge. So I'm really excited about it.
Yeah, it is really exciting. Can you maybe dive in a little bit more of how those cross-chain apps are not really what cross-chain apps are supposed to be.
You mean why they have not been possible, or why we need to abstract away their plumbing?
More in like you just criticize some like the terminology of using the
Got
the
you.
nomenclature of cross-chain apps
Yeah,
when they're not really cross-chain apps. They're just kind of like
yeah,
another intermediate, so to speak.
yeah. Yeah, absolutely. Yeah, anything cross-chain up until today that hasn't used like zero knowledge up until today, you can safely ignore because they are not what they claim to be. So, if we're talking about chains that claim to be the connection or the connective tissue between different blockchains, what exactly is happening underneath? Well, really, the only thing, you have a deposit contract on this blockchain and another on another blockchain controlled by this supposedly trustless blockchain, which is yet another blockchain in the middle. And so when you deposit into Ethereum and this cross-chain chain says, oh, we're going to teleport you to Polkadot, for example. First of all, there is nothing really actually moving or flying, or there's no message happening or anything. What happens is they, through their node, they look at your transaction here and then they unlock something there for you. So it's lock and mint most of the time. Some of them have some sort of arbitrary messages, but in general, it's you lock here, we burn there. But throughout the whole process, your asset is in the control of this new chain. You are not being secured by the home chain nor the destination chain in most cases. And then they throw so much marketing material on top of all of that. It would take you a lot of work to actually get to the what's happening underneath, which is in 99% of the time, it's just basically this, a contract in both chains that is under the control of this sidechain. When it comes to apps, it's also basically the same thing. This app might be using one of these cross chains, side chains, or they may themselves be creating the contracts in both home and destination chain, and they are assuming liability or control of the assets. So 99% of cross-chain stuff is actually not trustless. You are inserting new trust assumptions up until today, with probably maybe one or two exceptions that I can think of. Yeah.
What exception would that be?
Okay, so if you wanted to create a trustless connection between two separate states, obviously we know the rollup paradigm. So the rollups are good examples of something that is trustless. You can have your own rollup yourself, that is just doing your own app-specific rollup, let's say. But even earlier than rollups, the bridge between Near and Ethereum is it's an optimistic bridge, meaning you can actually you do not have to trust anyone in the middle between Near and Ethereum in order to mint a synthetic DAI, say, on Near that is matched by a DAI on Ethereum. And that bridge actually is very robust. It has been tested in the wild, and it's an example of a cross-chain interaction that does not introduce any new assumptions other than the assumptions of the two chains. And the way it works is actually pretty simple. So if someone tries to claim on Ethereum that, hey, I am entitled to redeeming 100 DAI on Ethereum because I burned it on Near, let's say. But that is not true. That didn't happen actually on Near. You can take a piece of a Merkle proof, basically, from the latest states of Near, hand it over to submit it to the contract on Ethereum, and there's basically Solidity code that would verify that, oh, okay, I am satisfied that this is the latest state of Near, and according to this latest states, that 100 DAI has not been burned on Near. Therefore, this guy should not have requested this. Therefore, I am going to slash the relayer that pushed this invalid request. But if you look at the implementation of that one, it's not trivial. It took some work to do it, and it's very, if you are thinking while I'm speaking that, oh, that sounds like optimistic rollups, that's basically the design pattern, except that here it's very specific. It's very specific to the minting and releasing, basically, as opposed to optimistic rollups, which have a general purpose state that moves from one block to another.
What are your views on the CCIP from Chainlink?
I looked into it very briefly, like I skimmed through it, and basically, okay, well, the short answer is, and ZK is going to transform oracles in general. You are not going to need to, you're not going to have to anymore to trust intermediary nodes for the updates that they make. So I would say CCIP is, I don't know if it's out there already and people using it. Maybe I have no idea, but I think it would be outperformed easily by the things I have been describing, by validity proofs that can prove to a blockchain a certain state in some other blockchain. And not only that, we will be able to prove fairly cheaply things about off-chain computations without having to trust yet another node in between. Right now, if let's take the ETHUSD price ticker, what would be the most reliable data point? It would be something like, okay, it's the median of Uniswap, ETHUSDC plus Binance plus Kraken plus Coinbase, etc., etc. So you can, in a single off-chain app today, prove all of these updates together and into a single snark, and provide that snark to a contract on Ethereum and say, here's the latest ETHUSD price. How did you prove centralized exchanges? Well, let's say they all agreed to provide or to sign with their public key the ETHUSD price at a certain minute. So you can prove the correctness of that public key's signature in the snark circuit. And then you have another snark that proves that the storage slot on Ethereum that corresponds to the ETHUSDC price in the latest block, let's say block N, is equal to such and such. And then you take all these proofs and you will recursively, you will create a meta proof of all of them together into yet another snark that proves all of them together. So this snark was correct and that snark was correct, etc. And it will also, the outer circuit, the circuit that is combining all the proofs together, will also contain the computation of the median function, which you can easily do in Circom. So all of this, you can imagine this and multiply it by 1,000. So you have massive amount of off-chain data that you can feed into a snark circuit, and you will generate a proof. And that on Ethereum, it costs the same thing, verifying or proving to Ethereum, verifying 1 billion facts, or a computation that involves a billion data points, or a computation that involves only 2 points. It costs exactly the same. And it's exactly this fact that will make ZK-powered oracles generally win in the long run. It's just so reliable, robust, and efficient.
On the same thread, what are your thoughts on optimistic rollups?
So yeah, optimistic. They are. It depends on which. So maybe I can give a story of how optimistic rollups came about. So it wasn't always clear that interactive interactive fault proofs is the winning paradigm. So what does that mean? Basically, if you go now to the Arbitrum contract on Ethereum and you say, hey, I'm here to report a fraud that happened in the last Arbitrum block. Interactive fault proof says, okay, we are not going to ask you to prove that the transition from block n-1 to block n was incorrect. We're not going to do that just yet. Instead, we're going to ask you, the whistleblower, where did the fault happen? Did it happen in the first half of the computation or the second half? So you would say, I claim that it's in the first half. And then this bisection continues on and on with the participation of the whistleblower and the sequencer who might challenge it, down to a single opcode transition on the rollup. An EVM transition. And once you reach like a single transition, then the contract on Ethereum will simulate or emulate that transition, and it will know whether it was correct or not. Anyway, so this is the mechanism at the heart of optimistic rollups generally, is this game back and forth to decide where the fault has happened before we actually recreate the computation that it allegedly led to it. This is what makes it work, and this is what fundamentally makes it work better than previous designs like Plasma and things like that. So it's a very elegant mechanism. Arbitrum invented it, and they worked many years on it until they finally delivered it. It's very elegant. It's also, one of its advantages, allows you to experiment with different runtimes much faster than you would otherwise be able to do using ZK rollups. And so I just mentioned that at the heart of optimistic rollups is this interactive game. And one of the things that this interactive game requires is that the runtime that is happening on L2 is always deterministic. Let's say it's a restricted subset of the EVM that doesn't introduce any sort of non-determinism. And we need this because, as I mentioned, we need to replay any computation that happened in the past in order to decide whether a fraud has happened or not. And so this whole apparatus that we call optimistic rollup, you can create new instantiations by replacing this core, this transition function. Instead of using, let's say, the EVM, you can use WASM, which is what Arbitrum did, for example. Optimism is saying, okay, we're going to try something even different. We're going to compile the entire Geth into something called MIPS, for example, So in short, optimistic rollups allow you to experiment with these different runtimes on L2 much faster than you would be able to do with ZK rollups. On the other hand, obviously, it comes with its advantages, like the in terms of like finality. With ZK rollups, if something is submitted, it's done and done. That's it. It's finalized. With optimistic rollups, you still have that window that must be allowed for anyone to report fraud. But it's not a big deal because, as we know, there has been some ways around it using liquidity providers and things like that. So optimistic rollups are here to stay, and there is no there is no rule that says you can't combine the two, because it is very possible. We have the tools today, actually, to prove on Ethereum that, hey, in the past, there hasn't been any fraud claim on Arbitrum or Optimism for the past 1 hour or 1 day or whatever, Oracle period you would like. So you can combine the two, actually. So that's a proof of a negative. You can also prove while the optimistic rollup is in production and getting traction and gaining user, you can also in parallel work on a way to prove in ZK the positive. There is no fraud up until block X in Optimism or Arbitrum. And right now we do have the ability to prove something like that, because proving systems are flourishing. There are so many choices now. I just saw someone recently took an entire Ubuntu instance, Linux instance, and they proved its execution trace in zero knowledge using risk zero. So things are moving fast, but what someone who likes optimistic rollups might say is that, hey, let the dust settles with these zero knowledge proof systems. Meanwhile, we will continue with providing scalability short term and attracting users and things like that. So eventually, I think ZK is going to invade optimistic rollups just in the same way that it's gonna invade everything else.
Yeah, that's very interesting. I've never even entertained this possibility, but after you mention it, it's just like, yeah, why not? What do you think would be the main benefits of having a hybrid system?
Optimistic rollups is much easier, relatively easier to experiment with new runtimes. So you can have WASM runtime, you can have EVM runtime, you can have anything that guarantees determinism. You can have it as a rollup, as long as its execution is always deterministic, whether you run it now or at any time in the future. This is the fundamental requirement. Again, it's so that when there is a claim of fraud, we replay the execution and it will always lead to the same thing. So the reason why ZK will, the question is why ZK will eventually invade optimistic rollup. Was that the question?
The question was, what do you think would be the main benefits from combining optimistic rollups with ZK rollups? What would be the
Got you.
The main value?
You basically get the best of the two worlds. You get the much hardened claim of the ZK rollups. This block is valid and it's done and done. While at the same time, you get to experiment and iterate much quicker with arguably less risk in terms of the attack surface and in terms of how much new code are you adding. So if, let's say, Arbitrum tomorrow decided to experiment with let's say a restricted deterministic subset of Java, let's say, runtime, the JVM, let's say. There is a lot of plumbing that is already out there. The plumbing that they have now for WASM and the EVM, they can reuse it, the same thing. All they have to do is gut out the core of the WASM core or the EVM core and just put the JVM into it. So you can iterate quicker with optimistic rollups. But this is not very strong advantage because ZK is moving very fast as well and maturing. I don't know how fast it will mature. We could have a catastrophic bugs tomorrow and it will set the ZK space back years maybe, I don't know. But yeah, I would say quick iteration is the main advantage of optimistic rollups.
Yeah, interesting. So they're thinking the long term, ZK is more likely to just take over everything, right?
I think ZK, or I should say validity proofs, are going to permeate everything, and even beyond the blockchain, because they have the power to extinguish inefficiencies, overhead in so many contexts. So yeah, I really expect it to transform so many things in the blockchains and beyond. Yeah.
Can we dive into some of the things that you're really excited about outside of the blockchain that validity proofs can be really impactful?
Yeah. So more generally, like in our societies, we try to like enshrine transparency or fight corruptions by creating, laws, regulations, inserting basically human attention or, and things like that. But first of all, it's not efficient. It's very costly. It doesn't work. It itself, processes that we put in place for transparency or things like that, they themselves can get corrupted and so on. And so it may take decades to get there because you need to re-architect the whole thing. You need to, there's a lot that needs to be done before you can prove something in ZK, for example. But you can imagine any intergovernmental interaction happening in full privacy and with full with proof of validity. So if people usually bring the use cases like not revealing your personal information and things like that. But I'm thinking even at a much lower level thing where any REST API request that is going on right now between governments, between institutions, between corporations, you can imagine that interaction being proven to the counterparty as opposed to being simply provided. So that, company A just responded to the API request and provided the information. Yes, it cannot be attacked, unlikely to be attacked in the middle because it's TLS encrypted and so on. But what guarantee do you have that in the back end of company A, the correct database was probed and this data came from the correct location and so on? So in the long run, I expect every database management system, everything to be wrapped with validity proofs somehow, and there will be a lot of aggregation, compositions, things like that, so that an API response that you get will contain much more or will convey a lot more context as to how valid it is. It will say, this part, the median has been computed correctly. That public key has confirmed this, or that the database in that specific hash has been used to retrieve the data, and so on. Obviously, in AI, it's going to have a lot of impact. You can, if we expect people to be using AI a lot, which is very likely to be the case, you want to know that what you got back has, if you're paying for the service, especially, you want to know for sure that the entire LLM has been used, or the correct version. You are not paying, like, you're paying for beta, but yet they're still giving you results from alpha or something like that. So you can expect in the future every AI response to have a snark attached to it.
What industry would you think that would be able to get the most value out of this rearrangement of plumbing, as in has the most overhead that can be extracted away by ZK?
Probably the blockchain, because of its permissionless nature and its adversarial environment. So in other contexts, we already sort of have things working without it somehow. Maybe not really well, but in the blockchain, if you are not robust, if it's not robust, it's useless. So I think the biggest impact will be there in permissionless environments. It's sort of like something that will harden every corner of the blockchain, sort of. You have the hardening effect, but then you have the abstraction effect, where we will be able to abstract away all this blockchain infrastructure from developers. So in terms of impact, I would say it will be in the blockchain space still.
So when is the next ZK fellowship happening?
The only thing I can say at the moment is that it's happening soon. And by soon, I mean weeks, not months.
Okay, very soon.
Yeah. We received so many questions about this, and I do apologize to everyone for, we can't respond individually to inquiries about the fellowships, but there is a lot that goes into a fellowship, whether it's a smart contract or ZK. A lot of things have to be in place before we announce. But yeah, it's the ZK fellowship is happening soon. There's a lot happening in the background in preparation for it. So yeah, stay tuned.
Awesome. And do you have any tips for people applying?
Okay, well, maybe I could say if you have been toying around with Rust and you have something that you can show, then you should, because Rust is going to be a factor. The code base that we will be looking into is most likely going to be the Nova code base. Nova is a folding scheme. It's not a proving system by itself. It's sort of something you bolt into whatever other proving system. It's like a pre-processing, or it's a way of doing snark. So we are likely to be doing that code base, and it's written in Rust. So one way you can get started is in ZK generally, Rust is the language of choice, especially for infrastructure. For the infrastructure part of it, like provers, for example, and circuits. If you want to familiarize yourself with how the fellowship proceeds generally, look at the pilot, see its organization, look at the sessions, how do you feel about them, things like that. Check out the approach that I explained that we are following in terms of explaining the computational model in one part, and then explaining the math in isolation or in segments, basically, and see if that clicks with you. So yeah, these are some of the things that I encourage people to get into if they are interested.
Awesome. And what are your thoughts on the security landscape at the moment, and in the foreseeable future? How do you think that's going?
There has been progress in terms of, I would say, habits or caveats or SDKs, things like that. But we're still very behind in terms of the number of security-minded, or I would say security-conscious, security-competent developers and auditors in the space. We still need to multiply that by 1,000, maybe even more. I don't know. By the next time we have a big wave of code bases being pushed and people putting money into them, I don't know if we're going to be ready. I don't know if we're going to, by that time, have multiplied the number of auditors in the space by 1,000. But we're working on it. A lot of projects are working on it as well. And one of the good things about the ecosystem is that different projects are coming at this problem, the problem of scaling security, getting as many people on board as possible in different ways and at different levels as well. So there is a lot of complementary projects out there. You can think of the output of this project, people who go through this. This program are the perfect input to the other program and things like that. So these are great. They were not there. None of that was there 2 years ago, 3 years ago. So that's good. So the situation has improved a lot, but in terms of scale, we still have a long way to go.
Yeah, I agree. I hope we can keep bringing in more people to the space. I wish you had a little more time. I feel like we could keep talking for a while. So maybe we can do a round two some point in the future, because I feel like there's so much that I wish you could cover. But it's been a pleasure. It's been really great talking to you. I think what you're doing for the space is really amazing. And I'm really keen to see all the people that come out of the yAcademy fellowships, man.
Yeah, likewise. This was fun. Thank you for inviting me.